In this section, we're going to use square roots in order to solve equations, but this video is actually going to address how to simplify square roots, such as the square root of 625 or the square root of 600, whether or not they come out to a nice number or not, and how to break them down, what rules work and don't work as far as square roots go. The biggest thing you want to realize about a square root is that square roots are the inverse, or they cancel things that are squared. So a squared square rooted is really just a, as noted in the upper right here in the rules. The square root of a squared, the order in which you do those two operations doesn't really matter. Again, that also comes out to a. Now, we also have a couple of rules saying that the square root of a times the square root of b is really the same thing as the square root of a times b inside. So again, multiplying two square roots, you can make it a single square root, or a better idea, more importantly, multiplying under a square root can be split up, and the same thing goes for division. Two separate square roots divided can be one square root with division underneath, or vice versa. Also realize that the square root symbol is actually called the radical, if you hear me refer to it with that name, and what's underneath your square root is called the radicand. Again, that number underneath, and that's really what we're going to be breaking down most of the time when it comes to square roots. So the big thing you want to realize, again, if you're multiplying two square roots, you can either break it into two separate roots or make it one single root. So if we have the square root of 625, one thing you want to realize is if I can break that into the square root of 25 times the square root of 25, essentially that's the square root of 25 squared. It's those two things multiplied together. And remember, square roots squared cancel away, and your answer is just 25. Now you can also check that on your calculator. The nice part is a lot of square roots, if they do come out nice and clean, you can see that on your calculator very quickly. So let's go ahead and open up a new page here so we can just clear this out. What we can say is control, and right above your x squared next to your 4 here is your square root symbol, 625. And if you hit enter, you'll notice that comes out to a nice clean 25. Now you might have noticed the next example was the square root of 600. And when we do that, you'll notice we get a nice decimal here. And yes, it is a repeating decimal. But the unfortunate part is, no, I don't think it's going to come out as clean as we want it to. So let's go ahead and try the square root of 600. Again, try breaking that up. And a great idea is to use a factor tree. Now, I'm not going to rewrite the square roots all the time, but a 600 can be broken into 6 and 100. 100 being 10 and 10, 6 being a 2 and a 3. Typically I'll go all the way to prime numbers and then circle them when I get there. But when I see a couple of 10s, I can also stop there. We could go to 2 and 5, 2 and 5. But if I see a couple of 10s, well, the square root of 2 times the square root of 3 times the square root of 10 squared, notice we had two of them, remember, it's just going to break down into a 10. Square root of 10 squared is really just 10. Then the two other square roots that we're left with, square root of 2 and the square root of 3, we can multiply those back together because they're not going to reduce. So I can leave that as the square root of 6. And that is a simplified exact value. Notice we didn't round anything off, but we simplified. We took as much out of the radicand, the number underneath, as we could. Now you might notice that sort of already broken down would be the square root of 9 times 16. And again, there's a great idea to break it up into two separate square roots, because the square root of 9, remember, is just 3. The square root of 16 is just 4, and 3 times 4 is a clean answer of 12. So separating those things, much like if we separated the square root of 2025 divided by the square root of 9, you'll notice that on the bottom of the fraction, square root of 9 is 3. And the square root of 2025 I'm not really familiar with, so I'm going to at least try breaking that down and see if it comes up nice and clean, and it does at a 45. And realize 3 goes into 45 15 times, 15 times, which is our answer. Now we could have actually taken 9 divided directly into 2025. You'll notice we do that on the calculator. We divide by 9, and you'll get 225. So another route we could have taken with this one would have been saying the square root of 225, which again comes up cleanly to 15. Again, the order in which you do those things doesn't really make a big difference. Let's go ahead. On the next page, we've got 4 different examples here. Go ahead and pause the video now, record your 4 examples, and see if you can't simplify them down. Alright, you'll notice in the upper left, I noticed that the square root of 12 could be broken into the square root of 3 times the square root of 4. The square root of 4 being a perfect square, so I can make that into 2, and the square root of 3 just stays as is. Over here at the right, I noticed 3 and 27 seem somewhat related. When I think about 27s, I think about the fact that 3 goes into it. So rather than breaking that down and seeing what I got, I went ahead and put it together, made it the square root of 81, multiplied those two things underneath the root first, and the square root of 81 I know comes up to a clean 9. Again, we could have also broken down the square root of 27 into 3 root 3, would have been a 9 and a couple of, or put in triple 3 underneath, one of which can come on the outside. In fact, let's go ahead and show you the work for that if we did this a little bit differently. Let's erase that real quick. And so we could have broken this into a 9 and a 3, and then 9 is 3 and 3. And realize that again, this 3 on its own, 1, 2 makes 3, and a couple more 3's on the inside is another solid 3 on the outside. Any pair of numbers, again, in your breakdown, become a solid number on the outside. And remember, 3 times 3 is 9. Square root of 15, square root of 81, I went ahead and broke up that division because square root of 81 I already know comes out to a solid 9. Now 15 unfortunately is a 5 and a 3, so I just put that right back together because square root of 15 really doesn't go anywhere. The best you're going to get is root 15 over 9. And finally 48 I broke into 3 and 16. Then the 16 broke up into 4 separate 2's. You'll see how I broke those down, which means, again, I'm going to look for pairs of numbers. Square roots, we're looking for something squared underneath, something where there's 2 of them. So when I see a couple of 2's, I'm going to put that 2 on the outside. Another couple of 2's is another 2 outside of my root, and that leftover 3 gets left behind. Remember, leftovers go back in the fridge. 2 times 2 is 4, square root of 3 is left over, and there is our answer. Now, the last thing to do with simplifying square roots is just something called rationalizing the denominator. That's when you have a square root in the denominator. We call that an irrational denominator. It's an irrational number. It doesn't come out to a nice, clean integer of any sort. Well, in order to get that root off the bottom, we need to cancel it. So the best thing to do is multiply the top and the bottom by whatever root you have. So you'll notice in the upper left I've got a square root of 3. So I'm going to multiply both the top and the bottom by the square root of 3. Root 3 times root 3 on the bottom is just 3. The 2 on the outside of the root on top stays outside, and the leftover root that's on top stays inside. And the best you're going to get as far as a rational denominator, notice a nice rational number now, a 3 in the denominator, is 2 root 3 over 3. Now on the right side here, you'll notice 2 divided by 1 plus root 3. If all you did was multiplied times root 3 right here, you'll notice you have to distribute. And just alone on the bottom, you're going to end up getting root 3 when you distribute times the 1 plus 3. Well, now unfortunately we didn't get rid of the root. The first term just became the root instead of the second one. So instead of doing that, I'm just going to go ahead and back up here real quick. Instead of doing that, what we're going to do is multiply what's called the conjugate. Since we have a 1 plus root 3 in the denominator, we want to multiply by 1 minus root 3 in the denominator. When you FOIL those two together, you'll notice the bottom of our fraction here becomes a 1 minus root 3 from the outside, plus root 3 from the inside, and then finally root 3 times root 3, but don't forget one of them is negative, becomes a negative 3 on the bottom here. On top, again, just a simple distribute, so that 2 goes to both parts. On the bottom, these two root 3's cancel. 1 minus root 3 becomes negative 2. And again, the top is just there. And then finally, I noticed that there's a 2 in all 3 of the terms that we can see. So we went ahead and canceled that out. So 2 divided by negative 2 was negative 1. And negative 2 divided by negative 2 times another root 3 becomes just a plus root 3. Don't forget that when you're dividing into 2 parts, to distribute there. Divide both pieces, both terms, by negative 2. You got a couple examples on the bottom here. Go ahead and use both ideas from the top and show us how to rationalize the denominator. Again, I'll pause the video, go ahead and try it out, and then I'll put on the answers for you. All right, in the example on the left, you'll notice that we separated it out. First of all, separate the fraction into root 5 over root 2. Then again, don't worry about the top root. We're only worried about the fact that that's a root 2 in the denominator. So I multiplied by root 2 on the bottom, and then root 2 on the top. Root 5 times root 2 is root 10, and root 2 times root 2 is just 2. Notice that 2 does go into 10, but since 10 is under the square root, under that radical, 2 is not underneath a radical, we cannot cancel those two things. So the best you're going to get is root 10 divided by 2. On the right side, you'll notice it was 5 minus root 2 in the denominator. So I went ahead and multiplied by 5 plus root 2 using, again, that conjugate, switching out that middle sign. When we FOILed those together, you notice that in the middle you get a plus 5 root 2 and a negative 5 root 2 that are going to cancel away. So 25 minus 2 becomes 23. And on the top, distributing the 4, we get 20 plus 4 root 2. And unfortunately, since 23 doesn't have any factors in common with 20 or 4, we can't cancel anything away. So your final answer is 20 plus 4 root 2 over 23. I hope that helps you with rationalizing the denominator as well as simplifying square roots. In just another video or so, we'll show you how to use square roots to solve equations. Good luck and happy math!